Today we discuss about compound gear train. Firstly, what is a compound gear train? In compound gear train, each intermediate shaft carries two wheels. Wheels mean gears. So one of which acts as a follower and other as a driver to the different shaft. In compound gear train, we consider a shaft A on which gear 1 is mounted, that is matching with gear 2 that is mounted on shaft B. So here gear 1 is matching with gear 2 and velocity ratio for gear 1 and 2, that is N1 upon N2 equal to T2 upon T1. This is equation 1. Here N1 is speed of gear 1, N2 speed of gear 2, T2 number of teeth on gear 2 and T1 is number of teeth on gear 1. So another gear is also mounted on shaft B, that is gear 3, and this is another shaft C on which gear 4 is mounted and that is matching with gear 3. Similarly, the velocity ratio for gear 3 and gear 4, here gear 3 is acting as a driver and gear 4 is a driven. Then velocity ratio for both the gears, that is N3 upon N4 equal to T4 upon T3. N3 speed of gear 3, N4 speed of gear 4. T4 is the number of teeth on gear 4 and T3 is the number of teeth on gear 3. That is equation number 2. And here is another gear that is mounted on shaft C, that is gear 5, and this is shaft D on which gear 6 is mounted, and gear 5 and gear 6 are matching with each other for transmitting the motion from shaft C to shaft D. The velocity ratio for gear 5 and 6, here gear 5 is driver and gear 6 is driven. Then it is N5 upon N6 equal to T6 upon T5. N5 speed of gear 5, N6 speed of gear 6, T6 number of teeth on gear 6 and T5 number of teeth on gear 5. This is equation number 3. Now for calculating the velocity ratio of compound gear train, we multiply the equation 1, 2 and 3. Then we get N1 upon N2 into N3 upon N4 into N5 upon N6, that is equal to T2 upon T1 into T4 upon T3 into T6 upon T5. So here we can see gear 2 and gear 3 both are mounted on same shaft, gear 4 and gear 5 mounted on same shaft. So N2 equal to N3 and N4 equal to N5, because same speed is transmitted from gear 2 gear 3 and gear 4 to gear 5. Since N2 equal to N3 and N4 equal to N5, then we can cancel out N2 with N3 and N4 with N5. Then finally we get N1 upon N6 equal to T2 upon T1 into T4 upon T3 into T6 upon T5. Here the number of teeth on gears, they varies according to the diameter of the wheel. Here gear 2 and gear 3 both are gear is here. Gear 2 may be small and gear 3 may be big gear. So there is a variation in the number of teeth on the gears. So this is equation number 4, and velocity ratio, this is equal to, this is the product of number of teeth on driven gears to the product of number of teeth on driving gear. So in gear train, compound gear train, if we compare compound gear train with simple gear train, we find that by using small gears much speed reduction is obtained. As we can see in diagram, here is two type of the gears. One is small in size and another is big in size. So small gears producing the much speed reduction. So speed reduction is obtained from the first shaft to last shaft. If same speed reduction is to be done by simple gear train, the last gear has to be big in size. So here we can see small size gear, they are meshing with each other, transmitting the motion. Then big gear, that transferring the motion. So as we discussed in our whole video, we have gear 2 and gear 3 are the compounded gear on shaft B, and gear 4 and 5 are the compounded gear that are mounted on shaft C. So today we have learnt about compound gear train and how we can find out the velocity ratio of compound gear train. Subscribe to get more video on mechanical engineering topics Anuniverse 22. You may also like its Facebook page www.facebook.com/Anuniverse22. You may share this video among your friends and students also on social media, Facebook, Twitter, Google+, LinkedIn, etc. You can ask your queries by commenting. Give your suggestions if required. Thank you. Have a nice day.